This is not a ranking of machines. It is the story of engineers solving a fundamental problem, moving the planet. Modern civilization is built on excavating and transporting immense quantities of earth, operating on a scale that is difficult to comprehend. The work happens far from our cities, performed by hidden giants. Machines with a single tire taller than a story of a building. Their purpose is simple: carry impossible loads. 400 tons in a single trip. The global economy moves over 100 billion tons of raw materials each year, and these are the instruments of that colossal task. The fundamental question for their creators was always the same: how do you design a vehicle that can survive this punishment? It's a battle not just against weight, but against the environment itself, against terrain where ordinary technology is rendered useless. Our first hero begins its work where the road ends. In the remote logging tracts of Canada and the mining frontiers of Alaska, the ground itself is the enemy. It is a world of mud, ice, and unforgiving wilderness. For this environment, engineers designed a machine built around a single radical principle: the Western Star 6900XD. Its defining feature is a fundamental re-engineering of the chassis, the twin-steer system. A conventional truck concentrates the immense weight of its engine over a single front axle, a design that fails on soft ground. The Western Star distributes this load across two separate steering axles, 8 front tires instead of 4, less pressure, more control. This system provides radical stability, allowing the truck to float over terrain that would swallow a normal vehicle. Underneath, a 15.6-liter Detroit diesel engine provides the force, 625 horsepower. The engine note is a deep, even rumble, no strain, the sound of a beast confident in its power. This machine's resilience was proven in the ultimate test. One unit drove more than 1,500 kilometers across the Arctic Circle ice. A lone truck cuts a path through an endless expanse of white. A map traces the journey, a remote line stretching across the frozen north. A distance like driving from Edmonton to Yellowknife entirely on a frozen river. Its 8 front wheels bite into the slick ice, turning in perfect unison, without a single mechanical failure. The Western Star is an engineering answer to the challenge of extreme terrain. But where did the era of such giants even begin? To understand, we must return to the 1970s, to a machine that became a legend and the progenitor of its class: the Caterpillar 773. This machine set the standard. The Caterpillar 773 was not just another truck. It was the engineering answer that established a new benchmark for mechanical durability in open-pit mining. It became the blueprint for reliability. Launched in the late 1970s, its core mission was simple: move immense weight day after day without fail. An archival photo shows it rolling off the line, a clean giant in monochrome. Cut to today, an Arizona quarry. The same model, its yellow paint faded and scarred by decades of rock and heat, scratched, dented, still working. The engine's hour meter shows a number so high it seems impossible. Its sound is a deep, rolling V12 roar, a dry thunder that echoes across the quarry. This is the sound of 55 tons of payload on the move. That's the weight of 10 adult African elephants, transported in a single trip. For over 30 years, some of these original machines have remained in continuous service, a living testament to their design. The Caterpillar 773 proved that giants could be brutally reliable on the surface. But for the cramped tunnels deep underground where there is no room to turn, an entirely different machine was created in South Africa. In the world of giant machines, some operate under the open sky. Others are built for a different reality, a world of pressure, darkness, and rock deep beneath the Earth's surface. This is the domain of the WTW220E, a specialized hauler from South Africa, engineered not for sheer size, but for survival in confined spaces. Its task is to work in tunnels where giants like the Caterpillar 773 simply cannot fit. The 18-liter V8 engine produces 700 horsepower, but its true strength lies in the 2,900 newton-meters of torque, delivered through an all-wheel drive system. This allows it to grip slippery, steep ramps in gold and platinum mines, pulling heavy loads where others would fail. Its design is a testament to its hostile environment. The operator's cabin, enclosed in a heavy steel cage, looks less like a truck and more like a deep-sea bathyscaphe built to withstand immense pressure. It is a tool of pure function, and its toughness is legendary. There is a story from the mines. A 220E is working, its headlights cutting a lone path through a dark tunnel. A sudden roar echoes, and the tunnel vanishes in a cloud of dust and falling rock. Silence. Rescue teams dig for 2 days, eventually uncovering a corner of the buried machine. They clear the debris, expecting a wreck. Then, the engine turns over. It starts. This machine is the peak of engineering adapted for a subterranean world. But what happens on on the surface when size limits are removed and the goal is to transport the absolute maximum amount of material. After the Subterranean specialists, the surface industry demanded its own solution for maximum efficiency coal transport. The answer was a machine built for a single, relentless task: the Cress coal hauler. This is not a universal mining truck. It's an engineering response to a specific problem: moving massive volumes of coal inside thermal power plants. Its power plant is a Cummins V16 engine, delivering 2,700 horsepower. But its true innovation isn't power, it's the design. From a distance, it looks wrong: a hybrid of a giant forklift and a tractor. The operator's cabin is radically offset, pushed far to one side, sitting next to the dump bed instead of in front of it. Then you see the payload: 180 tons. This strange form has a function. The offset cabin provides a direct line of sight for the driver during loading and unloading. The bed itself tilts sideways, allowing for rapid dumping in confined industrial yards where a traditional rear dump truck simply cannot maneuver. It is a logistics machine, optimized for speed and repetition within a closed system. The result is a legend of durability. Some operators have spent their entire careers behind the wheel of a single Cress, driving the same machine for over 25 years. But if Cress was a narrow specialist for one task, the next machine became a true global standard, defining the rules of the game in quarries from the US to South America. Meet the Komatsu 930E. It is the industry's gold standard, built on a foundation of balance, power, and unflinching reliability. Its payload capacity is 320 tons. That is the weight of 2 adult blue whales moved in a single haul. Powering this giant is a V16 engine, generating 2,700 horsepower. This engine doesn't turn the wheels directly. It drives a massive alternator, converting mechanical force into electricity. That current then feeds electric motors housed within each rear wheel, delivering smooth and immense torque. Due to advanced engineering, the engine's roar is a consistent, controlled hum, less a raw explosion, more the sound of relentless efficiency. This combination made the 930E a global phenomenon, the default choice for major mining operations from North America to Chile. But its ultimate expression of reliability is not in the engine. It is in the trust placed in the machine itself. We see a standard Komatsu 930E, a human operator in the cab navigating the mine. Then a closer look. The cab is empty. The same 300-ton giant navigates the complex quarry roads, guided only by sensors and an onboard intelligence system. A revolution in logistics. Imagine it: entire fleets of 300-ton giants operating in a quarry without a single person behind the wheel. Autonomous 300-ton Komatsu trucks seemed like the technological limit, but the response from competitors at Caterpillar was not automation. It was pure crushing power, a machine that raised the stakes to 372 tons. This is the Caterpillar 798AC. Its scale is difficult to process. Standing over 7 meters tall, it is a 2-story house on wheels, a house whose vast dump bed could carry another entire home. The engineering behind its movement is just as immense. An 85-liter V20 engine generating 3,500 horsepower roars to life. But this colossal engine does not turn the wheels. It powers a massive onboard generator. That electricity then flows to dedicated AC motors housed within the rear wheels. The result, despite its colossal mass, is a surprisingly smooth acceleration. No jerks, just a constant wave of immense torque. The price for one of these machines exceeds that of a private jet. Yet in the world's largest mines, from Chile to Australia, this investment is a calculated one. It pays for itself through relentless efficiency, and yet, despite its record-breaking payload, the title of the most powerful truck of its time belonged to another. Caterpillar claimed the payload record, but in the race of titans, sheer weight is not the only metric. For years, the title of the world's most powerful truck belonged to a different giant, a masterpiece of German engineering, the Liebherr T282B. Its heart, a 90-liter V20 engine, 3,650 horsepower, a payload capacity of 365 tons, and a colossal 14,000 newton meters of torque. Its design is a study in contrasts, a clean, almost futuristic silhouette built for brutal efficiency. But beneath that calculated exterior is raw, overwhelming power. The engine doesn't turn the wheels directly. It powers a massive generator, feeding electricity to motors in the rear axle for constant, unrelenting force. Its physical presence is intimidating, yet operators build entire careers inside its high-mounted cab, a testament to its legendary reliability. For a long time, the Liebherr T282B was considered the absolute king of the quarry. For a long time. In the race for power, the winner isn't just bigger, it's smarter. How do you force a 3,500 horsepower engine to breathe where there is not enough oxygen? Japanese engineers from Komatsu delivered their answer: the Andes Mountains. The air is thin. A standard combustion engine suffocates, losing power with every meter of altitude. It sputters. It fails. Then the Komatsu 980E-5 appears. Its rugged, functional form a statement of purpose against the harsh landscape. It hauls 363 tons of rock. Its 18-cylinder engine emits a steady, powerful hum, a stark contrast to the thin, silent atmosphere. The engine does not falter. The secret is not just its massive 78-liter displacement, an equivalent to the engines of 50 passenger cars combined. The key is intelligence. An advanced electronic management system constantly adjusts the fuel and air intake, compensating for the lack of oxygen and forcing the machine to work at peak efficiency. An engineering paradox. A beast that thrives where others cannot breathe. This is a machine born from a specific problem, operating in the high-altitude mines of South America. It is a solution built of steel and code, proving that the ultimate engineering feat is not raw power, but adaptation. It's the conquest of an environment. Solving this challenge was a critical victory, but the answer to the problem was a single defiant number: 4,000 meters. If Japanese engineering conquered altitude, a new player from China changes the rules of the game. It focuses on efficiency. While other trucks burn fuel on descents, the XCMG XDE 440 learned to give it back. This is a machine built around a single, shocking number: 400 tons. It's the first in our lineup to cross this colossal threshold, setting a new benchmark for payload capacity. To move this weight, it relies on a 4,000 horsepower diesel engine that doesn't drive the wheels directly. Instead, it acts as a massive generator for a sophisticated electric drive system, but its true innovation is revealed on the downhill run. For a conventional truck, a loaded descent is a controlled burn, with brakes glowing red hot to dissipate the immense kinetic energy as waste. The XDE 440 thinks differently. Its electric motors reverse their function. They become generators. The massive force of the moving truck is captured, transformed, and converted back into electrical power, turning the force of its own braking back into electricity that feeds its systems. But while some engineers chase elegant efficiency, others answer the challenge with one method: uncompromising, total mass. Forget energy recovery. This is a machine that is a geological event on wheels. From Belarus, the BelAZ 75710. It is designed to solve the most extreme transport problems in the vast Siberian coal mines. Its solution is not intelligence, it is brute force. The truck is powered by two separate 65-liter V16 diesel engines. Together, they generate a combined output of 4,600 horsepower. It's not a simple engine roar, it is a stereo concussion, a synchronized tremor that vibrates the very ground it stands on. This power exists to move a single payload of 450 metric tons, nearly 500,000 kilograms, in one trip. To visualize its scale is to defy conventional logic. The truck's massive frame is longer and wider than a professional tennis court. It moves on 8 wheels, a rarity for this class. Each tire stands 4 meters tall. One tire alone weighs nearly 6 tons, the mass of a fully grown African elephant. All 8 wheels are driven, giving the Colossus immense traction. This is not just the world's biggest truck, it is the most massive land vehicle ever built in history. From the high-altitude specialist Komatsu, through the efficient newcomer XCMG, to the absolute record holder BelAZ, this is a special class of vehicle. They are not just trucks, they are mechanical monsters, masterpieces of engineering that build the world in silence, moving mountains to create the foundations of our lives. Each represents a different answer to the same colossal challenge of moving Earth, but the engineering race never stops. The questions now turn to the future. Which path is the way forward? The specialist, the innovator, or the titan of raw power? And the ultimate question remains: will these giants one day be replaced by fully electric and autonomous machines?